Luxonis has a grand vision, and they're doing it in a smart way. In this episode, I talked to Bradly Dillon from Luxonis. He's currently the CEO of Luxonis, but was the chief operating officer at the time of his interview. We talk about Luxonis's cameras, a robot platform they're making for education called Rae, which stands for Robotics Access for Everyone, RAE, and a cloud platform they're making for robot deployments called RobotHub, and how they have ambitions for it to become the robot app store. This interview will be especially interesting to folks who are curious about startups and business models in robotics. The way Luxonis is growing its vertical is a great example of how a company can reinvent itself as it grows. Also, hobbyists and companies looking for a good vision sensor will enjoy this interview as a way to check out Luxonis's approach and ecosystem. This is the Sense Think Act podcast. I'm Audro Nash. Thank you to our founding sponsor, Open Robotics. And now, here's my interview with Bradly Dillon. Hello, Bradly. Would you introduce yourself?
Hi, my name is Bradly Dillon, and I'm the Chief Operating Officer at Luxonis.
Would you tell me a bit about Luxonis?
Yeah, absolutely. So Luxonis is a global team of engineers that all kind of come together with the same shared vision of wanting to make robotic vision like easy and accessible for all. And when I say we're a global team of engineers, I really do mean it. Our headcount is 65, and 54 of them are engineers. So we really are a team that's just chock full of engineers, kind of located all over. We were founded 3.5 years ago. You might know us from like our Oak D and Oak D Lite products. And Luxonis, in addition to providing kind of the standard products that we offer, we do also do kind of customized products and then like AI, ML simulation services. Yeah, that's right. So our founder CEO, Brandon Gillis, he originally 5 years back was really excited about AI and kind of embedded devices and started to explore the space. And it was around that time, kind of late 2010s, that was where like a lot of capabilities were really being unlocked at the same time, both from like the silicon side, but then also from like the artificial intelligence side of things. And when his original idea, which he actually called me about it, was to do laser tag, but to do laser tag like in a really cool augmented kind of way. So basically think like you're playing laser tag, but the experience is like you're like a Marvel character, like in a Marvel movie or something like that. So I thought the idea was really cool from a tech perspective, but maybe not so much from the business side of things. Interestingly, when Brandon went and kind of pitched that to his friend network, he actually discovered some really tragic news that a couple of the engineering friends that he had experienced like bike accidents, or like a distracted automobile driver had hit them. And so one case there was a fatality, another case it led to like a permanent disability. So that really struck Brandon really hard. And he's thinking, gosh, like I can solve this problem if I can create a device that's sort of this kind of the smart device that can be put on the back of a bicycle, can determine with like depth perception and artificial intelligence that a car is going to hit the bike, and then do some type of an intervention, right? Like sound an alarm, try to shine a light, or maybe notify the bike rider to move over. And when Brandon went to do that, he actually discovered that it turns out that's like really hard to do. And basically you had to put together these disparate systems of hardware. So you had to get like a stereo pair, a 4K camera, an AI processor, and then try to figure out all of like the software and the firmware to make it all work. And so basically these machine vision systems, in the 2010s, enterprises were spending, years and multi-million dollars in a lot of cases to get them to work. So that was really the original origin story of where the Oak D came from, which is to say, okay, like we can create a device that has kind of like five big things. And so that's like, it's embedded. So it's incredibly like small size, small form factor, lightweight, low power, and then like really high performance. So like, lots of megapixels, low latency, and then having like the spatial aspect, obviously for depth. And then the big piece, in addition to that, is being able to have artificial intelligence and computer vision on device. So all that compute being done on the edge. And yeah, that's really how Luxonis and the whole in OakD got started.
And how did you get in? Like, how did you get involved?
Yeah, so I continued with talks with Brandon throughout kind of his startup journey. We actually met when we were undergrads in engineering at the University of Colorado. So he studied electrical engineering, and I studied mechanical engineering with a kind of a focus in mechatronics. And so we'd stayed in touch over the years, and we're always hoping to be able to work together one day. Yeah, it took me a little convincing, but last year, Brandon said, "Hey, we're actually opening up Luxonis for doing a safe fundraise. Would you be interested in investing?" And I was like, "Oh, hell yeah, I'd love to invest." And so after investing last year and kind of digging into a lot of the company's history and success, it was just like, gosh, this opportunity is like too good to pass up. And so I was like, please, can you please let me finally join? So I joined in February. So still ramping up on some stuff, but yeah, February of this year. So yeah, only been here for 8 months. It feels like 2 years. Like 8 months of startup life feels like 2 years in normal life. But yeah, I'm so happy. I'm so happy I joined. There's nothing I'd rather be doing.
Yeah, and so what kinds of things are you doing at Luxonis? So you're chief of operations, but like, what does that involve?
Yeah, so a few key things. So sales is one, and so we actually don't really have a sales team, but we have a lot of inbound opportunities where we jump on calls with customers, obviously, and talk through their use cases. A second one is operations. So, excuse me. We do build a physical product. So there's obviously a lot of manufacturing and logistics around that. A third one is services. So I mentioned that we provide things like AI ML simulation services with certain clients. And then the last thing I help with is kind of like the finance, accounting side of things.
Hmm. Yeah, you really do a lot. You have a lot of hats on. That's great. With I guess so because you guys have such a large engineering team. So you have like you said you're 54 engineers, you're 60 people. So you have like the rest is like do you count yourself as one of the engineers or you're not? So you're one of the like six other people or so that's doing all of the other administrative things of the whole company?
Yeah, I think it's up to 10 on the admin side, but yeah, it's basically myself and about around 10 other people that are doing all of the non-engineering stuff. And then from an engineering perspective, we really have like everybody across kind of the whole stack. So we have electrical engineers, mechanical engineers, firmware engineers, software engineers, machine learning engineers, industrial design, and then like 3D designers on the Unity side of things. So yeah, we really have kind of the whole range of engineering types, which is great to have all of that in house, obviously.
For sure. Yeah. And I want to ask more questions about the team, but probably later in the interview. So tell me a bit about your cameras. Tell me a bit about the Oak D and kind of where you guys are going.
Yeah, absolutely. So the kind of the Oak D, which the D stands for depth. So that's where there's the stereo pair. That and then the Oak One. So the one just means there's just an RGB camera and not depth. So these are kind of devices that the purpose of them really is to be the eyes and the brain behind any kind of robots. And when we think about robots, we actually think about two types. So we think about one type of robots where it's actually actuating something. So as some type of thing that's observing and then saying, "Oh, we want to move this arm, close that door," whatever it is. And then we have kind of a second kind of series of how we think about robots, which is trapped robots. And so trapped robots is where we think of it as is that it's something where a robot can actually eliminate the need for actuation and instead can gather the right kind of information to be able to kind of complete whatever the task is. So a good way to think about that analogy is take like autonomous checkout that we're all familiar with. And so if you were to ask like a little kid, like, how do you automate autonomous checkout? They'd say, oh, like the customer comes to the front with their shopping cart of items, and then you have a robot that like grabs the item, scans it, puts it in their bag, and then they walk out. Like, look, you've automated it. But in the case of it's like something like autonomous checkout, you could actually have a trapped robot that is sitting there and is able to observe everything it needs to make it so that the customer can grab the items, and just walk out, like Amazon's proven out as an example.
Yeah, those are really cool. Okay, so you have these two different models of robot.
Yeah, and so the way we think about it is really like that's sort of the two main purposes of what the robot can do. And then in terms of the kind of like the variations of the product that we have, so we have some of our devices are the power and connectivity is done with USB, and then some of it the power and connectivity is power over Ethernet. And then the power over Ethernet line, those are also like IP65 or 67 rated. So those are the more industrial versions that can be used in like the outdoor environments.
Yeah, that's like, is that like, I don't know, moisture and dust certification? Like, is that the IPv, whatever it is? It says it's rated to this amount of dust or this amount of moisture. Is that correct, or is it something else?
Yeah, that's exactly right. Yeah, so you have to do tests like that. You actually submerge it underwater and have to make sure that is able to continue to operate after that. So kind of think about it like the really cool watch that you have that allows you to do underwater use.
Yeah. Okay, so you're basically targeting applications that have a physical robot that are affecting the world, and you have ones that are just kind of sensing. I'm thinking of it like you have kind of like our name where it's sense, think, act. So you're targeting things that involve sense, thinking, and acting. And you're also targeting things that are sensing and thinking. So that might be like the checkout that you're talking about, where they just scan items. You're effectively sensing the barcode, and then you keep some sort of list of all the items in that checkout case, and then just bill them at some point. So you have those two markets in a sense, and then you have devices that range from like more hobbyist level devices all the way to more of like industry would use it. It can be wet or dusty or whatever it is, and they'll keep working. So you have those two spectrums in a sense.
Yeah, that's exactly right. So we really got our history really started with hobbyists. Our product definitely, if you look back at like the Oak D, was you definitely call it like designed by engineers for engineers. These are generally people that these would be the folks that like on a if it's a Saturday night, like they're wanting to do like something cool with our type of device. And then what that's done though is it's also like seeded the market where it turns out like a lot of these hobbyists, they also work at say in like a small, medium or enterprise sized business. And they're looking at these types of devices and going, wow, actually this can help improve something that we're doing at scale. So when we look at our business model, it's gotten now to where the majority of it, and certainly the majority of it long term, is actually with businesses. But we really does start with kind of the true engineer and the hobbyist. That's really kind of like seeded the market for us.
It's cool that you first go to hobbyists and then it kind of pulls you into the industrial space. Like that's very interesting. You get the people working on it on their Saturdays and things like this, as you've said, and then they want to use the product or use your cameras in the actual workplace because it's better. And then now you have all this demand from business. Like that's a very clever way to enter business rather than going directly to business.
Yeah, absolutely. When I joined Luxonis, actually, I thought that part of the role is I was going to be like dialing for dollars, like hey, like we did check out this device, check out this device, and it turns out in our sales process that like an incredibly high percentage of calls that we'll have for the first time, the enterprise customer will say, oh yeah, I've already played with the Oak D, like I played with it from your previous Kickstarter. I've been following you for a while. So I'd say probably approaching half of our sales calls, like our first sales calls, they've actually the hobbyist has kind of experimented with it before, and that's great. Obviously, for the when we're starting to work with companies that are trying to do stuff at scale, it's great because they see where we started, and then they see kind of the advances that we've made, and then it makes it just a lot more fun when people are already familiar and interested in your technology.
Hmm. That is so cool. And the original Oak D one, or Oak D, the first one, that one spun up. It began with the Kickstarter. Is that true?
Yeah, that's right. That's right. So for those of you on video, you might recognize the outline of this. So this was the original OAK-D that we did on a Kickstarter. We get a little more than like 5,000 backers from it, and yeah, that was how we got started.
Hmm. Okay, and then tell me about your upcoming, like, where are you guys headed? What are your like upcoming products you mentioned? So you actually have a current Kickstarter going, and tell me a bit about that.
Yeah, absolutely. So our approach to like product development is we want to be constantly cannibalizing ourselves. So we kind of know like the tides of creative destruction, either like we can try to control it or somebody else will. So we're very aggressive with product development. An example is that this year we actually launched our Series 2 of products, and our Series 2 of products already far outsells our Series 1. And we try to kind of continue that where hopefully, if we can pull it off, we're trying to launch like a new series of product every year. And when I say new series of products, I mean not just one, like multiple, model variations,
A
kind of like the
series,
ones.
yeah. So
Yeah,
it'll be a full spectrum, basically.
yeah, exactly. And so for what we're doing here with our Kickstarter is that we're introducing a product that we're calling Rae, which is Robot Access for Everyone. And the reason why we decided to do Rae is that we wanted to highlight a big step change in capability that we're going to have for our Series 3 of products that'll be rolling out in early 2023. And that big step change is that it now has it now is able to run Yocto Linux because it has an ARM A53. And so what that means is that you can actually use it to be the robot. And so to kind of demonstrate this capability, what we did is we said, let's actually build a robot. And that was really the idea behind Rae came. Is we said, okay, we'll actually build kind of a cool, kind of household STEM targeted type of robot. And this can really showcase to our customers what our Series 3 product will be able to do.
Hmm. Okay, that sounds awesome. I like the idea of kind of going from a practical thing of, or at least a lot more grounded in physical reality by trying to build a robot with yourself or build a robot with your product. What so what does the robot look like, or what does everything look like, I suppose?
Yeah, absolutely. So I'll actually share my screen for those that are watching the video, and I can kind of speak to what this will look like. So the Rae device it's about like 6 inches by 6 inches, about as thick as like a deck of cards. So you could think about it like something that not a whole lot bigger than say like just a couple iPhones, something that could sit on your desk. And then Rae is something that when you receive it, you'll be able to download kind of a new application that's called RobotHub. So you'll be able to pair with it with like Bluetooth and Wi-Fi. And then right out of the box, you'll be able to do all kinds of stuff. So what we're showing in the video here is you can do like remote control. You can do like autonomous mapping of your house. You can play games with it. Like this is an example of playing hide and go seek, which will be fun for kids where you basically can have a countdown timer. It has a speaker and a microphone to be able to do that. You can also do things like sentry mode. So this is where it's like going around and patrolling to basically find that person that keeps stealing your package. And then it'll have like an entire application where you can do things like face recognition and stuff. And then I'll actually pause here to kind of explain. So we've been developing the product for more than 6 months. We already put quite a bit into R&D. So this is actually one of our engineers, playing with it in real life.
That's really cool. So to me, you said it's 6 by 6. It just looks like a little tiny, like, I don't know, VCR player or something, like a 6 inch by 6 inch one, little black box. And so I assume that it has some little tiny wheels on the bottom that it drives around on. And then it just at the front of it is the whole set, the whole suite of cameras that you guys have on your devices, so you can see the world. And then is the only actuation the wheels, or does anything else on it move?
Yeah, that's right. So the only actuation is the wheels. So it has two encoded wheels, and then it also has a third one that makes it so that it can turn. And then the device actually has it has two rails on the top of it, so you can think of it kind of like a roof rack in your car, and that makes it so that if you want to do something like put an arm on top of it, that you'd be able to do that. And then yeah, it's pretty low profile.
How much can it like move around? Like what would be the payload? Like how large of an arm could I put on it? Because it's a small thing. I'd be surprised if you can put a large arm and it could drive around.
Yeah, we haven't set the exact specs on how much. I think we played around with putting a little bit of a payload on it. Like I think we're looking like 1 or 2 kilograms or something like that that it should be able to handle. One of the things in the development is we actually did we did increase our battery size, and we're
Oh yeah, and the
kind of
battery in there too.
yeah, and we're improving the from the initial version we have. We're like improving the like motor capability a little bit, so it can handle hopefully be able to handle a pretty decent payload for some of the stuff that we were looking at for what we figured some of the hobbyists would want to be able to put on it arm wise.
What about the thing I'm thinking about is like between rooms there are like often those little like metal gaps, whatever, like the little bump that you have in the doorway. Can it make it over this? Can it drive on carpet? Can it like I don't know, will it drive on tile or like with big gaps between them or how does it work driving around? Or how good is it for this?
Yeah, so we're happy with the first version. So the first version does well at being able to. It can handle a little bit of an incline. It can go over things like shag carpet, like I have in my office here. So yeah, it does pretty well there. Obviously, it is pretty low profile. So if you had something that was like a really raised up kind of like door
Like a little
jamb,
half inch metal bump kind of thing between doors is pretty common, I think. Would it make it over that or
Yeah, if I think it was a half inch, that'd be probably pushing the limits of it. If it's not able to kind of clear it.
gotcha. And does it have any like there's not so like a Roomba or at least some of the more modern ones, they seem to have I don't know if it's springs or if it's slightly actuated where the wheels can be lowered an additional distance from the body of it so you can go over larger things. Like I'm amazed that it like jumps onto some furniture in my house because it has a low base. This kind of thing. Does it's only wheels spinning around a rod. The rod doesn't move at all to give it more clearance for this.
Yeah, that's right. The axle, I don't believe the axle moves like up and down to be able to really climb.
And the camera, you can't change its pitch or anything. It's always fixed looking a direction. Is it correct?
Yeah, that's right. It's always fixed. But if you saw from if you were looking at the video, is just that from the vantage point that you're at, you really have the full field of view that you're going to want to have for any type of operation, like in a room.
Awesome. Well, that's really cool. What's the price point for this?
Yeah, so we spent a lot of difficult time on the price, as
I
you can
imagine it's always
imagine.
hard to price things.
Yeah, for sure. And I mentioned that I kind of help on the finance side of things. So when I first heard what we had in mind for pricing this, I was quite upset.
Really?
But
What is it? Is it so much lower than you would try to justify? Or what would like tell me about that? That maybe it's an interesting story.
yeah, so I mean, the thinking is like we want to make like robots accessible for all, and so that means just being very aggressive on the price point. And so the starting price point we're going to have for like the earliest of birds on our Kickstarter will be $299.
Oh, that's
Um,
good.
Yeah, and so we really felt like in the educational robot space that there's a lot of great options, but the price point, $500 and well above, like above $1,000, we felt like that was just kind of out of reach for some of the people that we were hoping to be able to purchase this. So we're starting at $299. I think eventually when we sell it for retail, it might be approaching $500, but it wouldn't be above that point.
I don't understand. So, oh, you're saying the Kickstarter people that are getting it kind of like on early special because they're investing in it, and that makes it so that you can tool up given some demand and they get it for a special discount. But then when you put it in retail, you're saying it'll be about 500.
Yeah, that's right. So for a Kickstarter, the earliest a bird price will be $299, and then it's going to have a few $50 step ups. And so the step ups will then go to like 350, 400, and then 450, and then that will be where like the campaign ends. And then those are obviously the people that are participating early, so we want to give them that better price. And then yeah, we currently have in mind the $500, but if we can get down the bill of materials low enough, we potentially would go lower than that. That's just kind of like the absolute ceiling of what we have in mind for pricing it.
Yeah, that was so one interview that I did with the Rec Foundation, who they make a lot of educational products, and they work with, oh, I forget who it is, but they make basically robots for kids, and they aim for like $100 or $150. I may misremember, but like around there. But that's like kids teaching them this kind of thing. Or I mean, then you have like the Turtle Bot, the most recent one, and it is 1500 or 1800 or this kind of thing, and it's also supposed to be targeting hobbyists, but probably like early companies or this kind of thing. But it would be really nice to have a very capable, inexpensive platform for people to learn on. Like for me, like nearly $2,000 is like a bit to justify. Like I'll have to talk with my partner. It's like I really want this kind of thing. Whereas like a few hundred, it's like okay, that's fine. I can get this to play on. So 500, 300 is like I'm pretty excited. 500 is like 1,000 is like I probably won't get it for where I'm at.
Yeah, definitely. And we do feel like from a hardware standpoint, there's quite a bit in there. So like Rae has actually five cameras. So it has three in the front, and then it has two in the back, and then it actually has like about a 1-inch size display, digital display on it. So we are trying to make it kind of like action packed with a lot of stuff, so that you're getting pretty good bang for your buck.
So do you guys have any camera or any sensors on it that are not cameras other than the encoders on the wheels?
So we also have
Maybe a
a six
microphone?
axis. Oh yeah, we have a microphone and a speaker, and then we also have like a 6-axis IMU.
Oh, cool. Okay. And then so tell me about all the cameras that you have on it. So you have the two in the back that gives you so basically you're generating a map around it and trying to help it navigate with all these cameras, or how does it work? How do the cameras behave, or what are the cameras for?
Yeah, so we have, like I mentioned, we have 5 cameras. So in the back of the device, we have two IMX 214s, and those provide like the stereo pair in the back, and it makes it so like kind of like if you're driving a new car, how you can see behind yourself at all times. It's a great thing to be able to have in the app. So when you're running the app, you're generally seeing, of course, like the bigger forward-looking view, but then you have like the smaller picture-in-picture rear view, which is great. And then at the front of the device, which you always kind of want to intentionally make these things seem like it has an intentional front and back to make it more intuitive for people that are using it. We also have 2 additional IMX 214s, but then we also have a 4K RGB camera as well. And then that's what makes it so that you have the nice high definition streaming that you'd be able to do to the app.
And so how do all those cameras fit together in terms of what the robot is sensing? So you have so just for the front, you have the ones in the front that use the disparity between the image, and they are used to get the 3D, and then you have your RGB one, which you can overlay on top of it but otherwise that's really just for a high quality image. Is that how they fit together, or how does it work?
Yeah, that's right. And sorry, a quick correction. I misspoke. Long day. So the stereo pair is actually the OV 9782s, and then the RGB is the IMX 214. So for listeners thinking that I'm crazy, I just wanted to correct that. And yeah, so the way the stereo pairs in the front and the back work is that you're taking like the left and the right, and you're fusing them together to be able to create the depth map. And you can think about that in the same way that we think about with human eyes. There's a very good reason why we have 2 of them. For anybody out there that knows of somebody that like to say like lost an eye, it is really difficult on the depth side of things. And then the distance that the stereo pair is apart is actually about the same distance that our eyes are, which is pretty interesting to kind of think about for how well that we're able to see depth. So the depth map is not super high precision, like it's probably accurate within plus or minus 3% or something like that. But spatially, you can see X, Y, Z. You can kind of see the world, obviously from behind the device and in front of the device. And that's great for doing different things like say like mapping a house.
Mm-hmm. Yeah, that is really cool. And then so you guys don't do like with the, let's see, there's the what's that? I'm blanking on the name. It's a common competitor to you guys. I think it's like D35 or anyways, they use, yeah, RealSense, Intel RealSense. They use something where they are actually emitting a pattern on the world, and then they look at that distortion. But I think they also use two cameras with to look at the disparity, but they kind of combine all that information because the distance between the cameras is not very good, not very big, so you don't get very accurate. I don't know, a very accurate distortion map or disparity map. Do you guys do any sort of emitter with it, or is it entirely the distance between them and the relative images?
Yeah, so it's something that we introduced in our series 2, and it quickly became very, very best selling. So for those of you that are seeing the video, this is actually what the version looks like with that has the infrared with it. So there's two aspects with the infrared. So one of it is just the illumination. So that makes it so that you can operate in nighttime or kind of low light environments. And then the other piece is there's a laser dot projector. And you can kind of think about that, kind of how you're describing, like basically a little kid just spray paints a bunch of dots on something. And so we call that for shorthand like active stereo rather than passive stereo. And that really improves the depth map. In particular, if you're looking at a surface, kind of like say the wall, like the wall behind me here, those types of surfaces that don't really have very much texture. And if you, as a human, you sometimes kind of get confused by those, right? When you look at a wall or you kind of go, whoa, like, is this a foot for me or 50 feet for me? It could be a little spooky, kind of like what it's like to like look through a chain link fence. And so what the active stereo does with that laser dot projector is really improves the performance for being able to have accurate depth, similar to like what you're saying with the RealSense.
Awesome. So you take the infrared, so you are projecting on the world with your infrared emitter, and that's outside of our visual spectrum, so we don't see it, but it's really like a little above red in frequency, I think. And then you look at that and how the dots are placed on the environment, and so from that you can kind of infer its 3D structure, and you use this in combination with your stereo cameras to solve quickly the I don't know, for 3D information about the world. Is it correct?
Yeah, that's absolutely correct. And I'll actually, for those on the video, I'll pull up an example so you can see what it looks like. But yeah, your description of that was exactly right. And the performance improvement is quite a bit. Hang on, let me share my screen.
Rather than just doing raw stereo with the disparity, because that's really computationally expensive, and so you can kind of like leverage both of these methods to solve it way faster, I think.
Yeah, exactly. So on the top, for those of you that are watching the video, is what like passive stereo would look like when you're looking at a kind of a bland surface like a wall. And then the bottom, you can see the active stereo. And so the left-hand side is what you are visually seeing, and then the right-hand side is the actual depth map. And so okay. Oh, so with the passive stereo, where you see it kind of being black, that's where the depth's kind of falling apart. It's not getting it right. But in the active stereo, you see just kind of a blue screen, which indicates that the depth's doing really well. And then it might not come through actually on the screen, but you can actually see the dots in the projector. on the bottom left here, and that's like the active stereo. Doing the actual projection there.
Huh. And so intuitively, the reason why you need, or this active stereo is way better, you said it, where it's like you can look at a blank wall and it kind of will trip you out a little bit as to how far away it is because it's featureless in a sense. And the way we do computer vision, or the disparity, at least when I implemented it in grad school at some point, it was like you're going to look for a feature, and a feature is like something that has like hard edges in a sense. So like a point is a really good one, or a vertical line or something like this. Um, and so if you have no features, you can't compare anything. And then that is probably why that it starts falling apart, because you're not really able to match anything, and thus you're not able to solve for the depth, especially on like a featureless wall or very smooth wall.
Yeah, that's exactly right. Yeah, so I mean, it's basically, obviously you're taking the two different images, and then when you combine them, if you're not able to kind of detect that disparity between them, then it gets difficult, and it really falls apart.
Yeah. Okay. And then how can I program this? Like how does it work? And so the robot is called Rae, correct? That's how we're referring to the robot?
Yeah, Rae, which stands for Robot Access for Everyone. So
For everyone, it's the robot access. I got RA, and then every EY, or how do you, just the Y and every?
like Robot Access for everyone, but you drop the four to make the acronym of RAE.
I see. I was thinking RAY. Gotcha.
Yeah, and then to answer your question on how do you program with it? So our kind of like the normal Oak devices that we have a Depth AI API, and so you're able to download that, and you can get up and running right away, and you can code with it with Python or C++. And then with Rae, where we're really trying to like kind of lower the barrier to entry for the most people that will be using it, they'll actually just be using the application, which is called RobotHub. And so RobotHub, they download on their smartphone or their tablet. And then the thinking is that like a little kid would be able to do something like, say, play hide and go seek. But then you could actually do some coding with it, with Python or C++ if you were doing something more advanced development wise.
Okay, so you have RobotHub, and RobotHub is kind of like the app for it, and it's connected to cloud infrastructure, or what's the tell me about RobotHub, I guess.
Yeah, definitely. So we're really excited about RobotHub, something we've been working on for quite some time. We have more than a dozen customers that are using it right now, like in alpha mode. And it's been great because we want to get feedback from them of all the stuff that's not working. And really, the thinking behind RobotHub is that for an Oak device today that you go and say deploy in the field somewhere, it's difficult to be able to at scale be able to use it in a meaningful kind of way, like for a business operation case. And what I mean by that is like if something's not going right with it, you kind of have to like be at the host computer for it, or you have to actually go to it and plug in and say, hey, like what's going on here. And so with RobotHub, it provides the ability to access the Oak devices from anywhere in the world. And obviously that includes Rae. And so it makes it so you can do things like stream the data that's from it. You can do like robot operating system logging. You could do like A/B testing, like if you're wanting to try to deploy. And then you can do things like, say you have a machine learning model that it's not performing very well. You can do something like set up like an automatic recording trigger. And this is really important for, let's say you have the example of I'll pick on strawberry picking, pun intended. So let's say you're using the device for strawberry picking, and you have a neural network to determine if the strawberry is like moldy or something like that. If the confidence in that model goes below a certain level, say 70%, then you could set up an automatic recording trigger and say, hey, like record 60 seconds of this so that like a machine learning engineer can take a look at it and figure out, hey, like what do we have to do to retrain this model so that we can get more confident on this? And if you think about that, like say like how your Ring doorbell works, right? Where you can say like, oh, if you detect motion, do a recording. And so this is really helpful for our devices. a typical Oak device is processing like 10 gigabytes per second of data, which is like, if you had thousands of those and you wanted to save all the recordings, you'd run
Yeah,
out
it's
of
quite a
space
lot.
pretty quick. Yeah, so that's where RobotHub can come in and make it so that you can collect some of that data, but in a smarter way. And then the other piece with RobotHub is the ability to develop applications with it. So, for example, with Rae, we'll have a lot of pre-built applications, kind of like we were talking about before. For example, like hide and go seek, sentry mode, things like that. And so that makes it so that you can do more than just stream with it and have the cloud host, but you can actually do applications with it.
Yeah, that's really cool. How do you guys, so for Robot Hub, so say I get I get a Rae robot. Um, I have to connect it to my Wi-Fi and then it connects to Robot Hub, or how do I connect it to my phone, like a Bluetooth device, and then from there, my phone will send it Wi-Fi credentials, and then it will join my network, and then from there it connects to Robot Hub, or how does it work?
Yeah, it's a good question. So I'm not particularly dialed in all the details, but it's the way you first described it there. So you're able to connect with it with your device with Bluetooth or Wi-Fi, and then the mobile connects to it.
Ah, and then how do you handle so it sounds like there's a lot of companies that are doing something kind of similar to what Robot Hub sounds like. I mean, so Transitive Robotics is doing like a very open source version of something fairly similar. And then in that interview, they listed a bunch of other competitors that are doing something where they have their own ecosystems for like managing this kind of thing, where you can upload data to the cloud, you can go and view logs, or you can maybe do like interfacing with a dashboard or sharing a camera or this kind of thing. How much of a focus is this? Are you solving a lot of the hard problems like intermittent connections? And I don't know, how much effort are you guys putting into making this? Like it sounds like this could be a bigger ambition of the company, of Luxonis to me, where it's trying to appear up, or it's trying to be part of the robotics community in an even broader sense, like a go-to platform in a sense. I guess, are you working on these really hard problems like connectivity, and does it kind of handle this, or and then how does this fit as with the ambitions of Luxonis?
Yeah, it's a great question. So you hit on a word that describes like what we're trying to do, which is we're trying to be a platform, and so we want to be able to be a platform for robotic perception. And we always knew that the cloud application layer was the last piece of the puzzle. So like for our first couple of years as an organization, we were really focused on getting the hardware, firmware, and software to work properly. But then we always knew that for these devices to really be capable, to be kind of deployed at scale and actually solve real world problems, that you really needed to have the ability to have the cloud development capability on top of it. So we are trying to solve those hard problems, and then in kind of addition to that, in conjunction, we are trying to tackle some of the difficult artificial intelligence problems as well. And the thinking there is like we know that. Like right now, if you wanted to solve a really difficult problem with AI, it's very, very expensive. And I mean, long term, we want to be able to really like commoditize that, right? And help be a part of that, where we want to make it so there's just like a mushroom cloud of solved cases where you go, okay, like if we can go out and solve this tough problem, then you can just go out and solve 1,000 of them, right? And that's how tech history's worked, right? Where like once one person does it, then you have a whole lot more. So we do want to be like the ecosystem for people to be able to do that. And yeah, Robot Hub is like definitely mission critical. But the thing I'll say though is that we fashion ourselves business model wise as a software company that monetizes when we sell hardware. And so if we look at the competitive landscape, there's a lot of companies that focus on the cloud development side of things, and like if we wanted to go get funded by a venture capitalist, it'd be much easier to say we're just we're enterprise SaaS, we're doing cloud. So we are taking a more kind of challenging path to say, well, we actually have figured this out all the way down to the hardware. And then the hope is that then like the entire ecosystem is much easier to use between like the Oak devices and then the RobotHub.
It's bottom up.
So we're not
top down.
Yeah, exactly. And we're not looking at RobotHub as, well, two things. We're not trying to like make a fortune on it. And then the second thing is that we are, it's only something where we're looking to use it with Oak hardware. So we're not trying to make it so that RobotHub can just be used on any hardware out there in the world. Like we want it to be part of the Luxonis, ecosystem.
That's an interesting bet to me, because it seems to me like things that spread generally work with everything else. It prioritizes being like, if you look at, I brought this example up a few times on the podcast, but if you look at like Lisp languages or C languages, Lisp languages, in my opinion, are way nicer. Like I really love programming in Lisp, but they're really hard to implement for the person implementing them on a new platform. Whereas C was fairly easy for people to write a compiler and then make it so you could actually run your C programs on all different hardware. It's like they made it so that it was easier to spread. And because of that, the language took off. So I would imagine that a better strategy would be to support all different hardware, but your hardware works probably the best for this kind of thing. It would be a weird, to me, it's like a weird handicap in a sense, choosing to only support your platforms versus every platform for this. I think it would make it limitedly useful because it's an ecosystem you have to buy into rather than something that's a useful framework for everything else, this kind of thing. What are your thoughts there?
Yeah, it's something that initially when I was learning about Luxonis before joining, I had a lot of questions with Rae to say, okay, like what's kind of this business model look like? I actually think a good canonical example to think of is like Peloton. And Peloton is had a little bit of
bikes or whatever they are.
Exercise bikes. Yeah. So Peloton's had a little bit of a tough time lately. If you follow them,
haven't they've nosedived in terms of value, right? Like their shares and stuff. Okay, but go ahead.
That's right.
I'm not really following, but I think I've heard. Okay.
Yeah. So when I was getting to know, kind of thinking about it, this is Peloton like 2021, not Peloton late 2022.
Well, but the story might be an example of why not to do it. Just saying.
Yeah.
But
I still want to hear the reason. Be a cautionary. Yeah. Well, in the case of Peloton, they ran into issues with like matching supply with demand, right? And that's always difficult. It's always a challenge when you're making a physical product. So in Peloton's case, early on with COVID, they had way too much demand, and then they created a ton of supply, and then it ended up with a ton of oversupply. And that's what led them to have some of the, if you look at their market cap, I think they maybe gone down like 90%. But the key insight from their business model when they got started up, this is before they, went public and, briefly became a nearly $40 billion company, is that they said, look, like we could create a smart device and hey, like, let's just put an iPad here. And we could just let's just contract out to other instructors and like, we could get this thing to market really quickly. Yeah. And so they said, let's figure out the whole stack. So they built a bike from the ground up. They built their own hardware. They built their own firmware and software that go on the device. And then they have their own ecosystem of instructors that they sell to their classes. So it's basically kind of like the classical like walled garden.
Or Apple is a great example.
I use Peloton so that, because obviously Apple is probably the better example, but maybe a little over.
And they didn't plummet recently. I mean, maybe they are. I don't know. The stock market's crazy these days, but yeah.
Yeah, so that's really the thinking there is that we're looking at a problem when it comes to like robotic vision, robotic perception, and it's like we know this problem is really hard, and we know that there's like a lot of advancements that need to come over the next 10 to 20 years for this to really work. We think the best way to tackle that is to have an entire tech stack that is really well coordinated together. we think that that will be the better way for customers to be able to solve these problems than to have to go out. And if you remember the original problem statement of like how Luxonis was formed, it was that you could do machine vision, but you had to piece together these different disparate systems. You had to get the 4K camera, the stereo camera, the AI processor. And it's just really difficult, right? You go, I have to buy these different things. And then the same goes when you go like up the stack, where you go, if I try to make this hardware compatible with this software, with this cloud and development layer, it's just a lot more challenging. So we really think that the best way to make robotic vision easy and accessible is to be the product platform play. I will completely grant you that it is a higher risk proposition because you really do have to nail the whole platform for it to have value. But we think if we can do it right, that there could be a lot of value.
Yeah, but also there may be, I mean, like to get value from your platforms, you're gonna have to integrate with different sensors, different motors, different, like people are gonna have to make things out of it. And so it's kind of like almost to me, it's like going, and maybe I don't understand it entirely, but I think of like when I talk to the people in manufacturing, what it sounds like manufacturing is there are around components, and they're trying to get away from this, but there are a bunch of domain specific languages for each of the components that they end up using. And that was a gigantic headache for them because, oh, you want to add one additional module, you need to make something so this thing talks to some other thing. And we may be going right back into that set of problems. We like come out a little bit and then go right back in, wanting to own the stack. Will it be different than that? Will you expose things through, but it becomes your own domain specific language in a sense if you keep your stack very tight, I suppose, rather than exposing interfaces.
Yeah, so like long term, we do want to be sensor agnostic. We want to be able to integrate with like any type of sensor that a customer is going to need. So we're already integrated with like dozens of like compact camera modules, for example. We're actually just bringing a couple online this month from a firmware support standpoint. And then also just like from the other sensors that we see in these devices that are critical. So like things like IMUs and microphones, like LiDAR, time of flight, things like that. So we really like long term. We view it as that we want to be we want to make it so that like whatever type of sensors that's needed to like best perceive the world for that application, that we have like a model that's available for that.
Do you think you guys are gonna end up re-implementing something kind of like the robot operating system? Or do you think you'll use it? Or I guess it sounds like you want to create your own stack. Um, where do you sit with this?
Yeah, so with Rae, we'll have ROS 2 will come pre-configured on it, and we don't have plans to say come up with our own robot operating system. So we do plan to use ROS. So there's a lot of aspects that we're not trying to recreate that we will be able to reuse from out there. What's great is a lot of systems out there are.
Because it sounds like an incredible uphill battle, and throwing out a lot of knowledge from a lot of different, I don't know, people who have tried these things.
Yeah, and being open source is something that's really like part of our ethos. So Rae will be open source, and we try to be as open source as possible. We only have a very small amount of our tech stack that's closed source, and it's mainly due to external forces. And so, when you look at some of the other tools that are out there, that are open source, we do really enjoy being able to use those, and we think that's important for being able to develop quickly.
Oh, that's awesome. So how does it? I don't quite understand how RobotHub works with robots, I suppose. So it's you'll have your devices, I'm imagining similar to Rae, but maybe you allow it so that you can connect other motors, other sensors, I don't know, what other things to it. So you have your kind of brain part with the computer and then some bit of processing. And then that will be in, like, Robot Hub talks to your robot brain part, and then your robot brain delegates to other parts of the robot. Is that how you're imagining it working?
Yeah, that's right. So if you were like an advanced user, for example, you could take Ray and you could put it on like your lawnmower, um, and you would actually could then be able to use it to like control the lawnmower with it. So it has ports for you to be able to connect, and then that's like how our Series 3 will be. Is that you'll have the ability to like connect to other devices. For example, like with Ray, like it's obviously connecting and controlling motors as an example, and then you can do that externally as well. So you have that host capability.
And then it runs, you said Yocto Linux? Did I hear it correctly? What is that and how is that related to Ubuntu?
Yeah, it's a good question. I don't know on the Ubuntu aspect of it, I do know that it has it has an ARM A53 1.5 gigahertz running Yocto Linux, and then yeah, I'm not sure on the Ubuntu piece. Might have to follow up on that one.
I mean, I don't know about Yocto Linux. I'm curious to why you choose Yocto Linux versus any of the other flavors of Linux.
Yeah, it's a good
Is it
question.
like a real-time
I
operating system, or is there like some you could, because like even with Ubuntu, I think you can grab the components you want. You can have a really minimal install and just grab what you want. So I wonder what benefit there is to Yocto Linux as opposed to any other Linux.
Yeah, so I don't know a ton of details there, but I think the thinking is that like Yocto Linux is kind of like the bare level that people are maybe going to be most familiar with or is easier to use. But I actually don't know the details over like comparing it to other types. I will say that for the visual processing unit that we chose for Ray and for Series 3, which is called our Robotic Vision Core 3, that's what came with it as standard. So that was some of.
It seems to be more specific to Internet of Things related applications. So maybe that's why you guys have chosen it.
Yeah, so I think the history there was really yeah, yeah, the history there of her kind of originally picking kind of the version that was before it was really around. It was one of the first visual processing units that made it so that it could support kind of these IoT devices for the type of stuff that we were doing.
Huh. Okay. And then what if, so if I have a robot and my robot has a Ray sitting on top and that Ray is delegating. Now say I have external computers to Ray on the thing. I have lower level computers that I want to have talking to or lower level microcontrollers or something, delegating to my motors how I want legged locomotion to work or something like this. Or I have GPUs that are sitting somewhere else. How will all this work? Like I want more than Ray works with out of the box on my platform.
Yeah, so I don't have like a ton of details that I know to share for like how the in and outs of it that it works there. So sorry, not super helpful on that
Ah, no
question.
worries. I mean, it's just cool to see if they're. I don't know because I don't quite understand it, and I want to understand how it's intended to be used. So to me, it sounds like Ray in its current form is more like an entry point into the actually. So you guys were doing sensing and thinking. It's an entry point into sense, think, and acting in a sense. And so you connect it to Robots Hub and the cloud infrastructure there. Um, and then maybe a broader way of having robotics platforms work with the cloud robots hub cloud will kind of come in the near future. I'm just trying to see how see if I understand it and how all the parts fit. But it seems like a first foray into this area to me.
Yeah, and the explanation that you provided there is yeah is accurate. So um, yeah. I think you described that well. And yeah, sorry not to be able to riff on some of the technical architecture as much.
Yeah, it's just it's a like there's some parts of it that seem very promising to me as you've described it, and there are some that I just don't understand. I think. Um, but it seems like a cool initiative, and it seems like you guys have a lot more in your ambition than just making sensors and like a nice interface to these, which is quite cool. And it's interesting to me just kind of thinking about this, where it seems like everyone seems to be realizing that, like, okay, we're getting robot behavior down, but now we're needing to figure out how to update them, how to coordinate them, how to do training and trigger recording for specific things you want to generate data on. Like, that's really cool. I really like that aspect of your robots hub. It screws me up because of RoboHub for this kind of thing. I have to think every time and stop myself. But so this, lost my train of thought. It seems very cool. Just trying to figure. Hmm.
Yeah, yeah, I completely agree with what you said there is that, we do think that there's a lot more that has to be done to be able to make robots to really be successful. Robots have had this like long history. It was back before we were born that, people were already creating movies showing like robots taking over the world and talking about, all of the things that could maybe come with it. And I do think now we're finally at the inflection point where I think that previously we're thinking of like with robotics where it maybe got tripped up was thinking about this sort of like all-purpose humanoid robot and kind of going, well, like actually there's real tangible problems that we can solve. And so you saw that like very early on with robots and say like automotive. Like a long time ago, you could go into an automotive factory and see really
Like the
advanced
60s or
robotics, right?
something. Hmm.
Yeah, exactly. And so I think now that we're getting to where like it's just crazy. Every week you see like a new robot that comes out where they're getting a lot better at being able to try to solve like a very tangible problem, kind of like the here and now. And I kind of equate this to like take like autonomous driving, right? So it's like 5 years ago, everybody was so excited. Like, I'm just going to jump into a car and it's going to like autonomously drive me everywhere. And the reality is that like, well, there's a lot of advances that can improve things now. They're like, oh, if you buy a new car, like you can auto follow and you can change lanes and stuff like that. And it's like solving those here and now problems, I think is really important. And so, yeah, we're excited to be on that like journey to be able to help robotics companies do that. And we do feel like there's a long ways to go, right? I mean, we're 3.5 years into this, and we keep trying to improve the tech stack. And so yeah, this will hopefully be like a good milestone in our journey, but we have a lot more to do.
Yeah. Well, what I was saying earlier and related to that is it seems like we're realizing we have behavior more or less, like not solved, but we can make robots do a lot of interesting things that can already provide value. But now it's like fleet management and managing data and how you do updates and all of these other logistics things. So it pushes things to the cloud. And it seems like there's a lot of competing approaches and competing companies that are all coming like and realizing this is going to be a big thing and trying to take their hand, or I don't know, take a try at it. And I like the unique thing from my perspective about how you guys are approaching this is you're starting with hardware and you're trying to kind of build up from there to make it so your cloud platform works really well with your hardware, which is really cool. It's a nice way to do that. Um, I don't know. So it's a cool thing. It's just, it feels like that's where a lot of software effort is being spent in the robotics community at the moment to me.
Yeah, I definitely will say that the hardest piece for us as an organization was getting the basically getting the firmware to work with the hardware. I mean, that was really the part. We use this term sometimes that we call it schlep, which is like a startup. You have to have something that you really go into full schlep mode, which basically means like you have to do the thing that people don't like to mess with. And that's a big part of creating the value. So yeah, we think we do like to think that was a lot of the effort to be able to get us to where we're at.
How do you guys, maybe you don't know this, but it would be interesting if you have thoughts on it. One of the things that I'm seeing that's quite cool, actually, Okay, got a cough. I'm recovering from a cold. But one of the things that is quite cool and also difficult with robotics is we're using a lot of open source software. And so you may be like, oh, I'm using this, I don't know, I'm using some sort of machine learning thing that I downloaded from the internet on my robot. And you want to make sure that it's bounded. Like you still want to use it, but you want to make sure it can't make just like random web calls or something. Will there be any security bounds put in place on Ray, do you think, for other people like running this on their Yocto Linux?
Yeah, that's a good question. So security is definitely important. It's something that we talk to customers about quite a bit. And when we think about Robot Hub, in some aspects, it's like we have to help our customer be able to figure that out. Obviously, in addition to needing to have the hooks to run kind of say like an application or a model, there's also the aspect of like what's being done with that data. Um, and so, yeah, it's something that we're probably still in like in the early days on of figuring out all of the aspects with it. But we for anything that would be like an application that would get deployed, or something like a neural network that'd be in Robot Hub. Like on our side, we would be doing all the security checks with it. Where it gets a bit more complicated for us is going to be like third party applications, like you brought up. And so we're working on putting together kind of like the policies and procedures over like how like making sure that we have a really high bar to before we would like approve something like that being there.
Oh, kind of like an app store or something where they like you review it and then you give people access to it. This kind of thing.
Yeah,
That's cool.
yeah. So somebody obviously could do something on their own, and that like they'll be able to kind of worry about those things like on their own. But we also are looking at having the capability of like third party applications as well that somebody could put into Robot Hub too.
I love the one thing that I think would be really cool if you guys include. I love the sandboxing of a language like Dino, where Dino is a JavaScript a TypeScript runtime environment, and you have to explicit or you can enable all, but you have the option to explicitly enable every permission. Like I'm going to give it access to this set of environmental variables or these network calls to this address, this kind of thing. And you can kind of sandbox your application in this way. I would love to see other things doing this. It's not really a notion that I see often in the robotics world. And I'm starting to see people use Docker in this way, where you explicitly give it a set of permissions. Um, but it'd be very cool to have very granular permission control or access control to different things. Like I'd be excited to see a push towards that.
Yeah, so it's something that like with the initial like Robot Hub application, like say for Ray, we are trying to make it so that there is a lot of capability for the user to make some of those adjustments. And then we also look forward to hearing from the community as we get this out there, which is something we're always really excited. Which is why we always rush to get new products out, is to kind of hear, okay, what are the additional types of like knobs and security settings that people will want in terms of turning something on off and stuff like that.
It's interesting because it sounds like you guys are taking more of a centralized approach where you'll anything that like people can hack on their own and do whatever, but for the most part, it's like you want it to go through you to see if it's valid. It kind of like it's similar to like the Apple App Store, if I'm understanding it, how you seem to be saying it now.
Yeah, so like for the hobbyists, they'll be able to like to develop and do stuff on their own. But yeah, for something where somebody says, "Hey, like I've got this," say like a hobbyist goes like, "Oh, I created this great application for myself. I actually think it would be like really useful to have for all of Luxonis customers." That's where then we have to go. Okay, like we would have to start to worry about saying like, this is people are trusting Luxonis that this application that they're going to be using from somebody else in Robot Hub is going to be up to snuff.
So do you think it'll ever become like a full-fledged app store in a sense? Like I want my robot to run this, 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 and then I'm going to string those together in this way, this kind of thing.
Yeah, we do. So it definitely won't be something that will be initially, but we do think that that's what the opportunity looks like long term. So when we think about how we're kind of going to market with RobotHub, there's actually really like two bases of participants that we really want long term. So one of them obviously is like the users and the customers, but then the other is actually going to be the developers to say, oh, okay, like this actually would be an opportunity to be able to develop with this. But that's really long term. Initially, we're just focused on kind of the customers, but then yeah, we do think long term that there's an opportunity for that with third party developers.
Awesome. So where do you, I know you've only been with Luxonis for 8 months or so, but you've been involved in conversations for probably before its existence with its founder. Where do you think it's headed? Like, project out like 2 to 5 years. Where do you think Luxonis will be? What do you think you guys will be making?
Yeah, it's interesting. I've talked about this type of question quite a bit since joining, and I think it's great. So we definitely, when we think about ourselves as an organization, we definitely have like a long term view, where we don't like we're not thinking about like we're not thinking about this being like a short ride, so to say. In a previous life, I was in private equity, and private equity basically says like we acquire something and we typically try to sell it in 5 years, and like we're done, like that's it. And we definitely don't view this, view Luxonis that way. We do want to be long term, and so when I think about 2 to 5 years out, I think about that we have a device that and a platform that's like actually achieved like our mission, which basically means that you could have somebody that say like in middle school or high school, like they're taking our devices and they're actually able to do something like do machine learning with it. And so I bring that example up because I'm saying like it would just actually be really easy. And then for us as an organization, I think 2 to 5 years out, like I was mentioning before, obviously like the long term play for us is really when it comes to enterprises. So what I really hope when I think about like the projects we're working on right now is that we have like a lot of really sticky solved problems where enterprises are actually solving them at scale. And so I think that that's like when I think about all the work we're doing today and I think forward, like that's what gets me most excited is just to go, okay, like we've taken something and we've automated a task that's like, really not very pleasant today, or we've eliminated like a risk. There's a lot of kind of just, dangerous stuff and accidents and stuff that happen out there that can really be eliminated. So that's what probably we're most excited about. So anyway, it's kind of a long rambling answer, but I to kind of summarize just, we view ourselves as long-term organization, and we're really about just like helping our customers win with solving problems.
Working on those thorny enterprise problems. That's cool. It's neat to see kind of the evolution of you guys going from the hobby community, which then gets its own and hobby for hardware, and also the software side of things. But you go from that, and then you go to a bit more enterprise as people get as you one like you're building up the manufacturing processes and things like this so that you can meet a larger demand and have higher quality and figure all that out. And then it goes, now you're in industry a little bit, and then you're in industry, but only for hardware. And then it's moving towards using that hardware and all the software and the hardware associated with solving a set of problems largely based on that hardware, which is quite cool. And growing just enterprise thorny problems. Yeah.
Yeah, I mean, basically, we would like the world out there to see us as like the de facto robotic perception platform. That they go, yeah, if we go and we use Luxonis, that's going to be the easiest way that we can do these robotic perception systems.
Awesome. How are you guys funded?
Yeah, so we're fortunate to have kind of a group in our network of friends and family that have provided the funding that we need to date, and so we've been able to do
The
it
bootstrapping.
without we haven't done something. Yeah, well, a combination of bootstrapping, but then yeah, we've done some friends and family rounds, and we've to this date like we haven't done something like go down the venture capital path, but yeah, we're
No
fortunate to
Series
be well
A, or I
funded.
mean, no seed rounds, no nothing like this. No seed investors.
Well, we had seed capital, and so we've had seed capital, and I mentioned at the start of the podcast that we also did like a safe round, and then we did an equity fundraising round actually back in June. We've had a few kind of like small rounds with friends and family, and we're fortunate that the business is we're profitable as a business,
That's
and the
wonderful.
business does appear. Yeah, thanks. It's hard work for sure,
Especially
but it
for a
does appear
hardware
like
company.
the
Three
business is
years in,
pretty.
that's nuts. Like that's absolutely wonderful.
Yeah, yeah. It does seem like the business is kind of reaching the point or near the point of kind of being sustainable on its own. In addition to product sales, we also have some of our service sales, and that's helped us be able to kind of to scale up. It is difficult with hardware, like you mentioned. The irony is like the faster your hardware sales grows, the more cash your business consumes. So that's always a challenge to keep up with, but we've been managing it pretty well so far.
Yeah, and efficiencies of scale and this kind of thing. So hopefully, the more your orders, the more you can grow your infrastructure, the more you can meet demand, this kind of thing.
Yeah, exactly. And we've done a lot when it comes to um, making improvements when it comes to like logistics and distribution. So we're actually up now to like we have like globally we have like 20 distributors, and we also do sell the product directly through our store, and that combination has made it that we're trying to make it so that we have the product like available to be able to ship quickly to customers all over the world. I think I checked it earlier today. I think we've shipped to 100 countries this year, like shipped into 100 countries. So, which is it's a lot of work from a logistics standpoint. Um, but we're continuing on to kind of trying to improve there. So we're expanding like our third party logistic capacity in Europe and the United States, which goes along with the distribution partners that we have. So we know that like obviously we can't compete with Amazon. Like we're not going to be able to get the package to you same day for free. But we're marching closer to making it so that like the customer experience outside of the actual product is really great.
I ordered something today, and it was set to come in 3 hours from when I ordered it, which is just insane. Like what? I don't. It's just insane that they can do this kind of thing. That sounds really great. Do you? How do you do your manufacturing for this? Because you guys are largely engineers. Are you contracting the manufacturing, or I don't, how does it work?
Yeah, that's right. So we use contract manufacturers, and so we don't do the manufacturing in house, but we are very tightly coupled with the manufacturing process. And we're also hands on with things like the like factory calibration of the devices, flashing them, stuff like that. So yeah, we have we have multiple contract manufacturers that we work with, and we're always kind of like trying to improve our capacity there.
Where are your manufacturers?
Yeah, so we have one of our primary manufacturers is located in Shenzhen, China, and then we're also working on a pilot with a contract manufacturer that's actually in the United States, and then we have some pilot programs we've been doing with a contract manufacturer in Europe as well, Romania specifically. So our goal long term is to have contract manufacturers that are located very close to our customers. I mentioned before we sell to like 100 countries. The distribution really is like 40% North America, 30% Europe, 20% Asia Pacific, and then 10% the rest of the world. So we really want to have the contract manufacturer options. If I'd say like look out 2 years from now, We want to have like kind of contract manufacturer option at like kind of all three of those major regions.
Is it how have like supply chain issues and like lockdowns and things affected your ability to manufacture in the last, I guess, the whole time you've joined or even before that, as you're aware?
Yeah, it's been a challenging procurement environment. We've actually been happy with it though, because it's helped differentiate us. Because we have all the engineering in house, like we're very nimble. So like if a component goes out of stock, then will work on creating a
Ah,
new design for
that's a
it.
nice thing of
For
verticals for
example,
sure.
yeah, exactly. So for example, like one of our main OAK products, we ended up having like seven different variations of design to basically say, okay, like which one's it going to be? Um, and the design process it's definitely a big part of it where you really have to flip the whole thing on its head. So typically a design engineer, what they would do is they like design a product, they would prototype it, and then they would like lock down the final design, and then they would mass produce it. And the reality is you actually have to do the whole thing backwards. So in this current environment, where you first have to go and find the components that you need and procure them, and then you have to then say, oh, I'm confident enough that I can make the design work with those components. And so while you're working on the design, you're burning down, say, like 6 month lead times. We've been really fortunate that like our flagship products, we haven't had a major stock out in our history over the last couple of years. And we feel good from a procurement standpoint looking ahead. We have, from the finance perspective, we have way too much inventory, which is frustrating, but that's what we have to do to ensure that we stay in stock. So, for example, with Rae, we've actually already purchased ahead some of the critical components that we need that have more like a 6 month lead time. And then we're also seeing that there's the procurement environment is improving, starting to improve a little bit. The other part of your question was around like COVID. So logistics is a challenge, but logistics has also been improving quite a bit. So, for example, with COVID, with China's kind of like zero COVID policy, we actually never had our manufacturing shut down, but we had situations where our product would ship to say a shipping center, and that shipping center in China would be shut down for like a rolling lockdown. So it made it, a little bit of an unpredictable environment. But we haven't had issues with logistics for at least the last like 3 4 months. It seems like that's gotten quite a bit better.
Ah, nice. And then kind of unrelated, how is it work? Your team, I saw online, your team is all around the world, and you mentioned it at the beginning that you have a global team. How is it working at a hardware company that's largely remote? I know you have small devices, but it's still interesting to me.
Yeah, yes, it's been interesting to me too. So we use Slack, and so Slack is definitely like the heartbeat of the company, and like things are happening 24/7, 365, which is one part really cool and one part terrifying. Um, and so yeah, the way we operate those is that obviously for people that are kind of more on the software side of things, it's not as critical that they're necessarily located in like an office. But for the people that are dealing with hardware, it actually is important to us. So even though like we are native remote for how we started, we actually now have 4 offices. And there's quite a big benefit to that. For example, like our office in Taiwan, we actually just opening a new office this month in Taipei, moving from a kind of a smaller location nearby. If you kind of think about going like, if you're a mechanical engineer, do we want to purchase like 10 3D printers, for example, and have them at 10 people's houses? It's like pretty inefficient, right? Yeah, it'd be chaos. So for those types of disciplines, it's really important to have an office to come to. The other places we have offices is we actually have 2 in Czech Republic, and then we have one in Slovenia. So those are kind of these hubs where not necessarily everybody's there all the time, but like for example in Slovenia, that's where we have some of our electrical engineers, and it's great for them to be able to have a place to go into. As you can imagine, they've got gadgets and testing equipment all over the
How did
place.
you guys choose to have hubs in like the Czech Republic and Slovenia? Um, is it like the less expensive labor, or like is the founder from there, or like why over there?
Yeah, it's a great question. So the history of our two founders, Brandon Gillis, and then actually the other one's named Vlad, is that they actually both formerly worked at Ubiquity, and so Ubiquity they provide things like like business Wi-Fi, um, and so Vlad basically kind of led the European effort for Ubiquity and is based in Czech Republic. So that was kind of some of the origins of where we have a team in Czech Republic. And yeah, it's not so much on I wouldn't so much call it like on the labor cost for what's attractive there. It's just that there's the if you just were trying to do what we're doing in the United States, it'd be difficult to. It's just difficult to find the people across the whole tech stack that are available and wanting to work on the type of thing that we're working on. And so by being global, it's just like it
You have a
unlocks
global talent
a lot
pool.
more people that be global talent pool. And one of the things that I actually thought was really interesting about us as an organization is like actually some of our team members they're not necessarily able to speak English professionally. But when you communicate primarily with Slack, you can make it so that people can translate. So our our communication is obviously all in English. But yeah, I mean, it's when you think about the like paradigm of attracting talent. Like I'm near Los Angeles, so like we could be headquartered in Los Angeles, and we could say, okay, we want to get like the best people in all of Los Angeles to work on this. But your pool of people that would be willing to do that is maybe I don't know, maybe there's 100 grand people in Los Angeles.
And then you have to pay them 250K or whatever it is. Also,
Yeah, for
if
sure,
they're like
for
highly
sure.
skilled in whatever it is that you need them for, and they're probably employed by at some other big company. I've heard this quite a bit for startups where it's very challenging to get the right people initially, especially for very skilled roles.
Yeah, exactly, exactly. And so you extend that analogy of like you go worldwide, that the labor pool that's available grows by like 100x, 1000x. But then you go, well, there's maybe I don't know the exact number, but like a billion English speakers, a billion and a half, whatever the number is. But then you go, oh, like why not just make it so like we could have anybody? It doesn't necessarily need to be fluent in English. And yeah, I mean, so like the people that are at Luxonis, they all are just have such a shared passion for what we're building, and so we don't want to have any barriers to like attracting those people.
One thing, kind of like one other strategy, possibly too. I love the idea of growing your labor pool, and it's hilarious to have Slack where you're using Translate within Slack. I think that's wonderful to open it up to such an extent. One thing that I had heard at another company they were also a hardware company that was starting out. They went to the top companies, so they'd go to Tesla or whatever, and they would like message an employee there and say, would you consult on this kind of thing? Or can we have 10 hours of your time a week or whatever? And that way they could find people too. And a lot of times people are willing to do this for them. I thought that was another clever strategy. But it's really interesting to just open up the labor pool for this kind of thing. I really like that.
Yeah, and we've actually had some of that experience. Not necessarily tapping somebody from big tech, but somebody that can kind of like wants to try to work on a couple of specific problems, but like on a part-time contracted basis, and then kind of just saying it's a great way, almost kind of like a mini internship, I guess you could call it. Uh, yeah, and then if things if things work out and it's like feels like a good fit, then then it can lead to something that's full time. Yeah.
Very cool. Let's see. Um, so where, so we've already said where you think you're going as a company. Where do you think robotics is going in the next, let's make it a little bigger, maybe 10 years or so, like 7 to 10 years, we could say. Where do you think it'll be?
Yeah, I mean, the way I see it is that like when we really think about like our vision as an organization is that like we think that anything out there in the world that's done by a human that's like mechanical, repetitive, mechanical or repetitive, or something where like a human has to observe the world and do something with that information. We think that within 10 years, we think like the bulk of that will be assisted by robots, and then probably expanding a little further, or like 20 years, we think that a lot of those will be like outright replaced. So I actually think about it as similar to like what a personal computer has done, where like if you go back in time, so many tasks that were done in the office, you had to do them manually and they took forever, right? And now there's just so much stuff that's in a laptop, and my laptop here has an AI processor in it, right? And so I do think that it'll be kind of, the revolution will be somewhat similar, but rather than like for office work, it'll be like for the real physical world. And we yeah, but that is definitely long-term view. Like we're talking, the next 10 to 20 years.
Mm-hmm. What do you think? So, I've heard that metaphor quite a bit, where it's like robotics is similar to personal computers. For personal computers, it was like the spreadsheet, maybe like one killer application that made it so you really needed a personal computer because it was just so superior to doing it by hand on paper. Um, what do you think that will be for robotics? Or I don't know, how will it fit in the Luxonis vision?
Yeah, yeah. I think it's a great question, because I think about the spreadsheet a lot. And like I think some people could argue, some people argue that like Excel is probably the most used programming language in the world, right? I have I've probably spent 10,000 hours in my career like just in Excel alone. It's incredible, right? Um, yeah, I mean, it's just incredible what you can do with it, right? I don't know. Well, I think it'll be really interesting to see what kind of like the canonical example comes out. I mean, I think some of the ones we've talked on the podcast today are pretty obvious. I think that are going to happen. Things like, say, autonomous driving, autonomous checkout. Those are the types of things that I think will be here pretty soon. But I don't. When I think about like the labor pool, and kind of like the things that people do today, I'm not sure what one will be the biggest or will ultimately be like the canonical example. If I made a prediction, I would know certainly I'd end up being wrong.
There's a small chance he could be right, but yeah. Okay, awesome. Do you have any links or contact info that you'd like to share with our watchers and listeners?
Yeah, definitely. So we can share some links for RobotHub. We also share links for kind of some of the Luxonis Oak devices, and then this new Rae product that we're coming out with here soon.
Awesome. All right. It's been nice talking to you. And I'll see everyone. Well, I guess bye, everyone.
Yeah, it's been great to talk to you too, Audra.